Hello everyone and welcome back to Post Network Academy. I am Bindeshwar and in this video you are going to understand a very important topic that is used in machine learning, artificial intelligence, statistics and also in deep learning, that is the mathematical expectation. So let us understand it, and if it seems you difficult for you, I will break it down step by step. So let's get started. So basically this video or unit will explain you about random variable. Basically its expectation provides a measure of central tendency, or you can say that average in probability distribution or average of a random variable. And expectation is useful in both discrete and continuous probability distribution. So let us define and explore. We will also understand addition and multiplication theorems of expectation. We will also solve mathematical problems related to expectations. So let us see first of all expectation of a discrete random variable. So that is defined as, you will write expected value of x summation over from this one, the value of random variables multiplied by its corresponding probabilities, and you will sum up, and that you will get expected value. And basically this is corresponding to f, that is if variable is not random, so that is basically xi fi. So probability is replaced by, frequency is replaced by probability, if you want to simply understand. Basically that fi upon n, that you will get, this is the probability. So you can compare, and that is a long run average. For a continuous random variable, you will replace summation with integration. So expectation is also known as the mean of probability distribution. Let us see an example. So a game involves drawing a card from a box containing numbered 1, 3 and 5. If card numbered X is drawn, the player wins 2 times rupees. So you will just find the expected winnings. So let us see that here how it is solved. So basically we have the value of x1, 3 and 5, and because 2 times winning, so just you will multiply it by 2 here, 3. For a 5 you have to multiply, thereafter you will multiply by corresponding probabilities, and thereafter you will get expectation here, that would be 6. So multiplying the values of random variables with probability, that is the expectation. Second one, here the value of probabilities, that random variables here. So just will multiply, that is and you can say that sales mangoes for each 20, that's why you will multiply by 20. If it is 1 rupees, so that 10. Here you will multiply, thereafter you will multiply it by probabilities. So you can compare this one, x1, p1, x2, p2, x3, p3, and just add them, you will get 290. So you have to understand the context of the problem also. Let us see continuous random variable and its expectation. So that is, you can say that's expected value of x, limit is from 0 to 1, and that x Density function is given here 2x. So just plug it here and integrate with respect to x, so that you will get here 3x is q upon 3, that will get, and if you plug the value you will get 2 upon 3. That is just matter of integration. Another one, the density function is 3 into 1 minus x square, and limit is from 0 to 1. So integration from 0 to 1, x into density function, and if you plug all the values, finally you will get 1 upon 4. Now let us see some properties. So here expected value of constant is constant, and if you multiply any constant to random variable, that constant will be outside of the expectation. Now if you combine both of them, so you will get the third one. So if you combine both of them, so that means expectation operators is linear in expressions. So let us see, we will also prove. So here expected value of k, that is here, and thereafter you can take k pi's, so that would be 1 because sum of all probabilities, so that would be k. Thereafter the same thing it is being proved, kx, that means here k xi pi, and k you will take outside, here you can take outside, so xi pi, that is the expected value of x. The same way if you combine both of them, here you can see that here it take a outside, so xi pi, here take b outside because only b here, so that would be 1, and that would be expected value of x, and this is what wanted to prove. Again for a continuous, the same pattern is there, nothing extra. Now let us see an example where probability distributions given, that is discrete one. So these are the value of x, and these are corresponding probabilities. So find out expected value of x, expected value of 2x plus 3, expected value of x square, and expected value of 4x minus 5. So let us start with x. So just we will multiply and we will add. So we will get expected value of x, and thereafter we will apply in, that is 1, 2, 4 here and 3, and we will apply here in 2 and 4, and that is a different one. So let us see that here, yes, probabilities and random variables here, values of random variables. So if you add them all, so you will get 0.2. Let us see 2x plus 3 is expectation, so that you can use the third property we have proved, and a 0.2. So what will happen? See that, very simple, 3.4. X square, instead of x is, you will multiply by x square. So just we have squared all probabilities. There is not any negative, and probabilities, don't square probabilities, remember, just square random variables, because expected value of x squares, that is, and after simplifying you will get 2.2. This one, that is again very simple, just plug the values of expected value of x. So we have learned how to define expectation, explained expectation, addition and multiplication theorem, discrete. So for more resources like videos, PDF, you can visit my website. If you want to support and if you want more videos, so subscribe my channel, follow my Facebook page and also LinkedIn page. So hope you understood the concept. Again, if you want to motivate me, subscribe my channel, follow my page, Facebook page, LinkedIn page and also visit my website. So thanks for watching the video.